When a massive cargo ship pulls into port and ties up at the berth, its oceanic voyage might be on pause, but the vessel itself is far from silent. Even completely stationary, a modern container ship remains intensely active. Deep inside its hull, heavy auxiliary diesel engines continue to run without interruption. Those engines are responsible for keeping the ship's vital systems alive, powering the massive refrigeration units that protect perishable goods, maintaining climate control, running heavy pumps, and keeping the lights on 24 hours a day. Because of this continuous energy demand, the idling ship functions as a heavy-duty floating power station, relentlessly burning fossil fuels the entire time it sits at the dock. That stationary combustion creates a serious environmental burden, especially given how closely industrial waterfronts hug residential neighborhoods in major coastal cities. Onboard generators pump out a steady stream of carbon dioxide, nitrogen oxides, and fine particulate matter, tiny toxic particles that disperse directly into the air breathed by dock workers and local communities. And the pollution isn't exclusively chemical. The mechanical operations of those diesel engines produce a constant low-frequency rumble and heavy vibration that permeate the surrounding area day and night. This invisible idling traps industrial exhaust within the port environment, creating a zone of concentrated pollution for both dock workers and nearby residential areas. The solution to this problem is a process known historically as cold ironing. The term comes from the age of coal-fired ships, when a vessel at berth would stop feeding its furnaces and let its massive iron engines physically cool down. Today, that concept has evolved into a highly advanced system called shore power. Instead of relying on internal engines, a docked ship can shut them off and draw electricity directly from the local terrestrial grid. Making that connection requires massive, standardized industrial hardware, starting with heavy-duty power cables packed with thick conductive cores, capable of carrying high-voltage electricity safely from the dock to the ship. Equipping a dock with this infrastructure transforms a simple maritime parking lot into a sophisticated electrical distribution hub. But plugging in a ship isn't like using a wall outlet. Ships built globally operate on unique voltages and frequencies, often drastically different from the local shore grid. To bridge that gap, heavy substations use transformers and converters to alter the incoming supply, matching the wave pattern exactly to the vessel's electrical requirements. Right before shutting down the diesel engines, advanced control systems inside the hull monitor the incoming grid power, carefully aligning it with the ship's active internal current. Once the phases are perfectly synchronized, the ship's entire electrical load transfers to the shore grid, allowing the onboard generators to spin down without interrupting the lights, the refrigeration units, or cargo handling systems. Achieving this absolute seamless power handoff is vital. A momentary drop in power during the handoff could reset computer systems, disrupt sensitive cargo storage, or delay unloading operations entirely. When this system activates, the results are immediate. Local emissions of nitrogen oxides and fine particulate matter drop by more than 95%. However, scaling this technology carries an enormous price tag. Ports must fund the installation of high-voltage capacities, massive substations, and complex cable management systems across miles of active docks. This chart shows the sheer scale of electrical demand at play. A single large cruise ship or container vessel requires enough raw electricity to rival the continuous power draw of an entire small city, putting massive strain on local utilities. Add in the fact that global fleets lack unified technical standards, and port authorities face intense pressure just to physically accommodate the varying plug types and voltage needs of international ships. The underlying engineering of shore power is already proven. The primary barrier today is coordinating the massive capital investment and standardizing the physical infrastructure across international borders. Despite the extreme costs, increasingly strict global climate regulations are leaving ship owners and terminal operators with little choice but to adapt and modernize. As a result, ports are transitioning into electrified energy hubs where ships run cleanly on grid power and zero-emission vehicles move cargo on the ground. As the maritime industry works to lower its massive carbon footprint, shore power stands out as the most practical, immediately available technology to cut emissions precisely where they harm people the most. By simply plugging in and powering down those diesel engines, global shipping is taking a concrete, mechanical step toward a quieter and cleaner maritime network.